Namaskar, Adab, Shat Sri Akal. Welcome to the 15th live class in group theory. And in this lecture, we are going to discuss homomorphism in group theorem. Yes, homomorphism, one of the most important concepts in group theory. And if anyone will ask you, have you read group theory? Then you can say about one or two chapters and everything will be concluded, है ना. आप होमोमॉर्फिज्म अगर सीख लेते हैं बहुत अच्छे से तो निश्चित तौर पे ग्रुप थ्योरी का जो मेन काम है वो हो जाता है. कैसे, क्यों हो जाता है? होमोमॉर्फिज्म अगर हम बड़े आसान भाषा में समझने की कोशिश करें तो कैसे समझेंगे? हाउ शैल वी अंडरस्टैंड? व्हाट इज द इंट्यूशन? सो आई वुड लाइक टू से, फॉर एग्जाम्पल, इफ आई हैव अ फोटोग्राफ ऑफ माई सेल्फ, अगर मेरा कोई जो फोटोग्राफ है ना, वो फोटोग्राफ मेरा होमोमॉर्फिक इमेज है, ठीक है. ठीक उसी तरीके से बहुत सारे ऐसे ग्रुप्स हैं, फंडामेंटल ग्रुप्स, जिसके बारे में हम बहुत सी बातें जानते हैं. लेकिन अगर हम ये जान गए कि वो मतलब वो ग्रुप जिसके बारे में हम नहीं जानते वो किसके होमोमॉर्फिक है, और जिसके होमोमॉर्फिक है अगर हम उस ग्रुप के बारे में जान गए तो उसकी सहायता से विद द हेल्प ऑफ दैट ग्रुप वी विल बी एबल टू अंडरस्टैंड अबाउट अ बिग क्लास ऑफ ग्रुप, है ना. बहुत सारे ग्रुप्स के बारे में हम चीज़ों को जान सकते हैं. आज शुरुआत में, in the beginning of this lecture, I would like to discuss what is homomorphism in a proper way. I will also discuss how many homomorphisms from a particular group to another group with different binary operations can be counted, है ना. homomorphisms कितने होंगे, ठीक है, उसको काउंट कैसे करें, जो शॉर्ट ट्रिक्स है वो बताएंगे, लेकिन शॉर्ट ट्रिक्स के पीछे का जो इंट्यूशन है वो क्या है वो भी बड़े अच्छे तरीके से बताएंगे. ओके. एंड बाइनरी ऑपरेशंस को लेकर जो कंफ्यूजन्स रहता है, आई विल ट्राई टू क्लियर ऑल दोस. ओके, सो लेट्स स्टार्ट दिस लाइव क्लास नंबर 15 and I will try to conclude homomorphism in just one shot. So let's start. Okay, so first of all, certainly we will try to understand the definition. Okay, so before coming to definition, I would like to write a group with binary operation this, and I would like to write another group with different binary operation. Yes, it is G dash with a star. Okay, and homomorphism is nothing but a mapping, a function. But which kind of functions? Okay, so certainly we are going to define a function. Let's call it f, or you can give any name. For example, if I am calling it phi, then certainly phi from this group G with this binary operation, okay, to with another group Z dash with binary operation, and we are just denoting it with the help of star. Okay, now you will see how we are going to define. So you can see two groups with two different binary operations and a mapping is over here. So this mapping is called homomorphism. Homomorphism. But when? Okay, yes, so I would like to tell you, yes, it is called a homomorphism. Certainly this phi is nothing but a mapping from Z with this binary operation to Z dash with this binary operation. The binary operation has taken different, okay, and certainly the non-empty sets are also different. Then how shall you define this homomorphism? So let's discuss how a homomorphism is going to be defined. Certainly phi of A not B. Okay, so I would like to tell you, I am taking just two binary operations like this and this. All right, all right. Someone is saying something. Okay, so just a second. Someone is saying something. अरे यार, I'm just coming back. Allow me 1 or 2 minutes, and thereafter I will continue this lecture. All right. So certainly I will give you a pictorial representation that how the binary operation works, right? So here you can see this was the binary operation. This is a general binary operation. I am not going to define the things by just taking addition or multiplication, some standard binary operations. No, not at all. I'm saying let's denote one binary operation this dot. Let's call it dot. ओके, इट्स जनरल है ना. जनरली हम इसको डॉट से डिफाइन कर रहे हैं, इसको स्टार से डिफाइन कर रहे हैं. यहां पे जो ग्रुप है ये जी से डिनोट हो रहा है, यहां पे जो ग्रुप है जी डैश से डिनोट हो रहा है. ओके, तो जो होमोमॉर्फिज्म है वो कुछ और नहीं बल्कि मैपिंग है. और यहां पे जो एलिमेंट्स हम ए और बी ले रहे हैं, ये मैं बता दूं ये जी से लिया गया है, आगे देखेंगे. एंड दिस इज इक्वल टू फाई ऑफ ए and phi of A, so certainly this phi of A will go in this G dash. Phi of A किसका एलिमेंट होगा? G dash का. और phi of B जो है ये भी किसका एलिमेंट होगा? G dash का. लेकिन G dash का जो बाइनरी ऑपरेशन है स्टार, तो certainly यहाँ पे स्टार लगाएंगे, है ना. You must be very careful for this. Okay, so what is the thing over here? I'm just going to repeat about the homomorphism. Yes, it is quite clear that homomorphism is nothing but a mapping from a group G with binary operation dot to a group G dash with binary operation star with this property phi of A dot B. Okay, A and B has taken from the group G, and that's why the binary operation of G, which is dot, is over here. But as you know, after the mapping, phi of A belongs to G dash and phi of B belongs to G dash, and the binary operation of G dash is a star. That's why here should be a star, here should be dot. Okay. अब कुछ लोग कहेंगे भैया हम इधर भी बाइनरी ऑपरेशन प्लस रखेंगे, इधर भी बाइनरी ऑपरेशन प्लस रखेंगे, तो ठीक है, यहां पे भी प्लस हो जाएगा, यहां पे भी प्लस हो जाएगा. कुछ कहेंगे कि हम इस डॉट के जगह पे एडिशन रखेंगे एंड इस स्टार के जगह पे आई वुड लाइक टू पुट मल्टीप्लिकेशन, तो उस केस में यहां पे एडिशन हो जाएगा, यहां पे मल्टीप्लिकेशन हो जाएगा. ओके, सो आई एम जस्ट गोइंग टू गिव यू अ पिक्टोरियल रिप्रेजेंटेशन टू क्लियर इच एंड एवरीथिंग. फॉर एग्जांपल, लेट्स से आई वुड लाइक टू से, लेट मी कंप्लीट द डेफिनेशन. फॉर ऑल a comma b belongs to Z. Okay, for every element A and B in G, phi of A dot B should be equals to phi of A star phi of B. Okay, so yeah, this is the thing. So now let me give you a clear cut picture. Let's say A and B are there and a map phi is there. So after mapping we will get phi of A comma phi of B, these two. All right, and when we are going to put a bind, then certainly we have to put the binary operation dot. क्यों? क्योंकि A और B are the elements from Z and the binary operation of Z is nothing but dot. That's why. So whenever we will operate A and B, certainly we have to put a dot over here because dot is the binary operation of Z. But after that, when you are going to apply this phi over this a dot b, then what are the things you are going to get? Phi of a dot b is equals to what? Certainly you will get phi of a, but phi of a and phi of b are the elements of what? Z dash, and that's why you must put star over here. Okay, so yes, this is a clear cut diagram. You should be very careful with the binary operations, right? If you are taking elements from Z, in that case you have to use the binary operation of Z like here. And if you are going to take the elements from Z dash like phi of a, phi of b, then you have to use the binary operation of Z dash, which is star over here. And what is the beautiful thing in homomorphism? Certainly this will be preserved. Okay, and that preservation is, yes, located in this red bracket. I mean to say phi of a dot b is equals to phi of a star phi of b. So this is how homomorphism is defined. Do you know? I will tell you the ideas. I will tell you the intuition behind the shortcuts, and certainly we'll discuss all the short tricks to count the number of homomorphisms for sure. Okay, so certainly one by one. So the definition is quite clear that two different groups with different binary operations will be there, and how we will operate the binary operation is quite clear. Phi of a dot b is equals to phi of a star phi of b for all a b belongs to Z. Now let me give you some example. Okay, how shall you say whether a particular mapping is a homomorphism or not? It will be really interesting to see. Okay, if I will tell you just one line justification may be there. If a map is over here Z6 to Z10, okay, certainly we are taking groups Z6 with respect to addition modulo 6, and we are taking Z10 with respect to addition modulo 10, and in that case you need to say, is this a homomorphism? Is this a group homomorphism? This is the question. Is f from Z6 to Z10 defined by f of x is equals to 2x a homomorphism? क्या f from Z6 से Z10 जो कि इस तरीके से डिफाइंड है f of x is equals to 2x के तौर पे, क्या यह होमोमॉर्फिज्म होगा? दिस इज द क्वेश्चन. ओके, एंड certainly within seconds you will be able to say, but before coming to that shortcut we must have to know what is the reason behind that shortcut, and that's why I'm taking a while. Okay, if anybody is there, then certainly they may put their answer. Otherwise, I can easily illustrate over here. The answer is, this is not going to be. Answer is no. Certainly, there is a beautiful result behind it, but before coming to that result, just by inspection, we can see what? Certainly, this Z6 contains the elements from 0, 1, 2, 3, 4, 5, you all know. Okay, so if you will take x is equals to 5 in Z6 and y is equals to 1 in Z6, then what are the things you are going to see such that f of 5 plus 1 is equals to f of 6. And what would you like to say? If you will take addition modulo 6 over here, then this is not 6. Actually, this is 0. Because if addition modulo 6 is over here, then 5 plus 1 is what? 6 divided by 6, and the remainder is 0. So you will say f of 0. And how the things were defined? F of x is equals to 2 into x. So certainly f of 0 is equals to 2 into 0, which is 0. So hence we can see f of 5 plus 1, f of 6 is 0 over here. Okay, but what about f of 5 and f of 1? Okay, तो यहां पे हमने क्या देखा, f of x plus y is 0. तो f of x plus y, f of x plus f of y के बराबर होना चाहिए. Only then we can say the things, right? So what are the things we can see? Just a second. Yes, f of 5. तो f of 5 क्या होगा? Okay, it will become 2 into 5 and plus 2 into 1. So certainly 2 into 5 will be what? 2 5s are 10. And what would you like to say about it? 2 into 1. So addition, multiplication model 10 will be over here. So it is 0. क्योंकि f of 5 is equals to 2 into 5. Okay, so it will become 0 and 2 into 1 will be 2. So this is 2, isn't it? So f of 5 plus f of 1, ये तो f of 1 है ना. So we should write the things like f of 5 plus f of 1. Okay, so f of 5 plus f of 1 is 2, but f of 5 plus 1 is 0. So you can see the binary operations are not preserved, isn't it? Hence you can see f of 5 plus 1 is not equals to f of 5 plus f of 1, and therefore f is not homo. इसीलिए f जो है homomorphism नहीं होगा. But what are the tricks? Because always you cannot just check by taking elements or by just checking, okay, manually. Certainly there are results by observing the facts. You can say the things within seconds. But before coming to that result, I just want to ask one more question. If I am taking f from z6 to z10 only, and if I am going to define it by f of x is equals to 5x, then my question is it a homomorphism? If anybody is there, then certainly they can say, and if nobody is there, then in the recorded lecture certainly they should try. If we are talking f from z6 to z10 defined by f of x is equals to 5x, will it be a homomorphism? What would you like to say? And what is the reason? Sometimes the answer is yes, sometimes the answer is no. So what is the result? Certainly I will come to that. But as you know my teaching style, I will not come to the shortcuts directly, but will go through the intuition concepts and everything. So do you know its answer is yes. Okay, so why this is? Because if you will take x and y, any element in z6 such that f of x plus y is equals to 5 into x plus y, then certainly it will become what? It will become what? Just a second. It will become 5x plus 5y. Always somebody will say ki, how can you say this? I will give you the reason, don't worry. And I would like to tell you, if you will take any elements from z6, you all know this z6 is nothing but this one. Okay, and if you will take any elements from z6, then certainly f of x plus y is going to become f of x plus f of y. Okay, and for all xy in z6, and therefore the answer is yes, it is a homomorphism. But what is the result behind it? When shall we say yes, it is a homomorphism, and when shall we say it is not a homomorphism? It is really interesting to see. So this result will help you to say the things easily. So what is the result? The result is, if you have a mapping f from Zm to Zn, okay, this result is for this Zm and Zn group only. Okay, so f from Zm to Zn, and let's say it is defined by, f of x is equals to ax, where a belongs to Zn. Remember, we are taking this a from Zn. Okay, this a belongs to Zn. Then the question is, sometimes this f of x is equals to ax is a homomorphism, and sometimes it is not going to be. So when shall we say that this is a homomorphism, and when shall we say this is not going to be a homomorphism? This will be really interesting. So if order of A is equals to k in Zn. Okay, let's say the order of A in Zn is equals to k, है ना. A का जो order Zn में है वो अगर k है तो Zm को एक एलिमेंट रखना पड़ेगा k order का. Yes, and Zm has elements. Zm has elements of order k. order k, ठीक है. Zm के पास एक एलिमेंट है order k का. Then f of x is equals to ax is a homomorphism. This is a very nice result. Okay, इसमें क्या है, f a mapping from Zm to Zn defined by f of x is equals to ax, where a belongs to Zn. order of a is equals to k in Zn. a का जो order है k, ये किसमें है, Zn के अंदर है. तो अगर Zm के पास k order का एक एलिमेंट है, in that case f of x is equals to ax is a homomorphism. So now if I will ask you a question, then by using the above results you should say the things very quickly. If I am defining a map f from Z4 to Z9 defined by f of x is equals to 4x, okay, a homomorphism. If this is a question, then what shall you say? Is it a homomorphism? Then the answer is no. Why? Because you can see that this f of x is equals to 4x, right? And the order of 4 in Zn is what? What is the order? Because we are talking about the order of 4 in Zn. What was the theory? The theory was what? If the order of A is equals to k in Zn, अगर A का order Zn के अंदर k है तो k order का एलिमेंट Zm के अंदर होना चाहिए, राइट? तो यहां पर 4 का जो order है Zn के अंदर, ये क्या है, 9 है. तो अब उस थ्योरम के हिसाब से 9 order का एलिमेंट, the order of element should be 9 and it should belongs to Z4. But unfortunately no elements of order 9 is there in Z4, and therefore the answer is what? No. So after knowing that result, you will be able to say the things quickly, isn't it? So certainly, as the order of 4 in Z9 is 9. Why the order of 4 in Z9 is 9? Because 4 plus 4 plus 4 9 times, and then if you will divide with 9, addition modulo 9, then you will get 0, है ना. Because Z9 को हम लोग एडिशन मोडुलो 9 के रिस्पेक्ट में चीज़ें देख रहे हैं, और अगर हम यहाँ पर 4 प्लस 4 प्लस 4 प्लस 4 9 टाइम्स करेंगे, फिर 9 से डिवाइड करेंगे, देन वी विल गेट 0. सो ऑर्डर ऑफ 4 इन Z9 इज 9, बट 9 ऑर्डर का कोई भी एलिमेंट Z4 में नहीं है. इसीलिए ये होमोमॉर्फिज्म नहीं होगा। ठीक है, तो आपने देखा कि रिजल्ट की सहायता से कैसे हमने तुरंत ये बता दिया कि ये होमोमॉर्फिज्म नहीं है विद द हेल्प ऑफ रिजल्ट। बट मैनुअली, ओके, मेथड 2, आई मीन टू से मेथड 2 कहने का मतलब वही है, इंस्पेक्शन से भी हम देख सकते हैं। इफ वी आर गोइंग टू टेक f of 3 plus 1, which is nothing but f of 4, so f of 4 is what? Certainly if you will take addition modulo 4, then 3 plus 1 modulo 4, so this is nothing but what? 0, because 3 plus 1 4 divided by 4, so 0, so f of 0 is what? 4 into 0 is equals to 0. But when you will try to see f of 3 plus f of 1, then in that case it is 4 into 3 plus 4 into 1. Okay, and in this case you can easily see we have to take certainly modulo 9, right? So what shall you say? F of 3 plus f of 4, so it will become 3 because multiplication modulo 9, and if here is multiplication modulo 9, then certainly this is 4, so this is 7. So f of 3 plus f of 1 is 7, but f of 3 plus 1 is 0. So you can see that f of 3 plus 1 is not equals to f of 3 plus f of 1, and therefore it is not a homomorphism. But with the help of the result, you are able to say the things within seconds. But with the help of inspection also, you can say this is not going to be a homomorphism. Okay, so now I would like to discuss a gate question. Okay, certainly short tricks are there, but what is the reason behind the short tricks is really interesting to see. So we are coming with a gate question which has asked in 2014 f of z3 to z9, and they have asked how many number of homomorphisms are there. So certainly one may easily say the answer is the GCD of 3 and 9. Okay, but what is the reason behind that? Certainly we will discuss also. So just one line justification and anybody can say 3. But this is not the actual way of going through with the concepts, है ना? कैसे आया GCD of 3 and 9? This is important, this is meaningful. Okay, ये तो होता ही है, अगर if this is m, this is n, then the greatest common divisor of m and n used to give the number of homomorphisms from for f from zm to zn. But why this is? What is the reason behind it? How shall you calculate it manually? This is interesting, and I will not skip the cream concepts. Okay, so I would like to give you the detailed concepts, the reason behind this formula in a proper manner. So if you have f from z3 to z9, so possible mapping for homomorphism are what? Possible mapping for homomorphisms. Possible mapping for homomorphisms are what? Certainly f1x is equals to 0 into x. So what would you like to say? Is it a homomorphism? Certainly yes. Why? Because the order of 0 in z9 you already know, and मतलब 0 का जो order है उस order का element z3 में भी है, certainly one order का, तो इसीलिए ये homomorphism हो जाएगा उस थ्योरम से। अब मैं आपसे पूछूंगा कि f of x, देखिए f2x is equals to 1 into x, क्या ये homomorphism होगा? तो आंसर है नहीं। कारण क्या है? क्योंकि द ऑर्डर ऑफ 1 का जो ऑर्डर है z9 में वो क्या है? 9 है, क्योंकि 1 प्लस 1 प्लस 1 प्लस 1 प्लस 1 9 टाइम्स करेंगे डिवाइडेड बाय 9, तो रिमाइंडर 0 आएगा। तो ऑर्डर ऑफ 1 जो है 9 है, लेकिन क्या 9 ऑर्डर का कोई भी एलिमेंट Z3 में है? तो आंसर है कि नहीं। इसीलिए F2x इज इक्वल टू 1 इंटू एक्स ये होमोमॉर्फिज्म नहीं होगा। देखिए, अगर कोई आपसे Zm से Zn में नंबर ऑफ होमोमॉर्फिज्म पूछता है, आप सीधे GCD ऑफ M और N कह देते हैं। लेकिन अगर सवाल में क्वेश्चन में ये आ गया कि Z3 से Z9 F2x बराबर 1 इंटू एक्स होमोमॉर्फिज्म है या नहीं है, तो उसको भी समझने के लिए चीज़ें होनी चाहिए। आप सिर्फ फॉर्मूला रट के काम करोगे तो ये डेंजरस हो सकता है। F3x की अगर मैं बात करूं तो ये क्या है? 2 इंटू एक्स। अब ये होमोमॉर्फिज्म है कि नहीं है? तो यहाँ पे 2 का अगर हम यहाँ पे देखें Z9 के अंदर ऑर्डर, तो 2 का भी ऑर्डर क्या होगा? 9 होगा, बिकॉज 2 प्लस 2 प्लस 2 प्लस 2 इस तरीके से। और उतने ऑर्डर का कोई भी एलिमेंट Z3 में नहीं है, तो इसलिए ये भी होमोमॉर्फिज्म नहीं होगा। ओके, यस, इन दिस वे इफ वी विल टेक 2x के बाद क्या 3x, तो 3x हो जाएगा होमोमॉर्फिज्म। क्यों? बिकॉज यू कैन सी द ऑर्डर ऑफ 3 इन Z9, ऑर्डर ऑफ 3 इन Z9 क्या है? ऑर्डर ऑफ 3 इन Z9 क्या है? 3 ही तो है। 3 प्लस 3 प्लस 3 9 डिवाइडेड बाय 9 रिमाइंडर इज 0। ठीक है, और 3 ऑर्डर का जो एलिमेंट है वो Z3 में है कि नहीं है? बिल्कुल है, तो ये होमोमॉर्फिज्म हो जाएगा। ठीक है, इस तरीके से देखना पड़ेगा। ठीक है, वो कितने होमोमॉर्फिज्म है सिर्फ उसको समझ लेने से ठीक है, आधा काम हो जाएगा। कई बार क्वेश्चन हो भी जाएंगे, लेकिन हमें यह भी समझना चाहिए कि कौन होमोमॉर्फिज्म होगा और कौन नहीं होगा। 4x होमोमॉर्फिज्म होगा कि नहीं? नहीं होगा, क्योंकि 4 का ऑर्डर फिर से 9 आ जाएगा। 9 ऑर्डर का कोई भी एलिमेंट Z3 में नहीं है। सिमिलरली अगर मैं यहाँ पे 5x की बात करूँ, 5x भी नहीं होगा। ठीक है, आपको बता दिया है थ्योरम। फिर अगर मैं यहाँ पे 6x की बात कर लूँ तो ये हो जाएगा, बिकॉज Z9 में 6 का ऑर्डर कितना है? 3 है। 6 प्लस 6 प्लस 6 18 डिवाइडेड बाई 9 0। ठीक है, लेकिन 3 ऑर्डर का एलिमेंट Z3 में भी है, तो ये हो जाएगा। ठीक है, तो हमने क्या देखा? F1x इज इक्वल टू 0x है ना, 3x एंड 6x, 3 होमोमॉर्फिज्म आर ओवर हेयर। और क्या क्या पॉसिबिलिटीज है? 7x, ये भी नहीं होगा। ठीक है, रीजन आपको पता है। 8x, ये भी नहीं होगा, क्योंकि 8 का जो ऑर्डर Z9 में है उतने ही ऑर्डर का कोई भी एलिमेंट Z3 में नहीं है। तो इसीलिए अगर हम यहाँ पे नंबर ऑफ होमोमॉर्फिज्म्स की बात करेंगे तो वो 3 होगा Z3 से Z9 में। और वो कौन कौन से होमोमॉर्फिज्म होंगे? देन इन दैट केस यू विल से कि एक होमोमॉर्फिज्म तो fx इज इक्वल टू 0x होगा, दूसरा होमोमॉर्फिज्म fx इज इक्वल टू 3x होगा, तीसरा होमोमॉर्फिज्म fx इज इक्वल टू 6x होगा। सो यस, दीज आर द 3 homomorphisms. So only 3 homomorphisms are possible. ठीक है, अब हम क्वेश्चन को थोड़ा सा रिवर्स करते हैं, क्योंकि ये गेट 2014 में आया था। हमने इस क्वेश्चन में क्या था? गेट 2014 में क्वेश्चन ये था कि f फ्रॉम Z3 से Z9 कितने होमोमॉर्फिज्म होंगे? ठीक है, तो 3 होंगे। Z9 से Z3 पूछेगा कितने होमोमॉर्फिज्म होंगे, तो वो भी 3 होंगे, लेकिन कौन कौन होंगे ये भी महत्वपूर्ण है। ठीक है, सिर्फ झटके में आंसर देना वो तो अच्छी बात है। अब Z3 से Z9 में 3 होमोमॉर्फिज्म्स कौन कौन से थे? fx इज इक्वल टू 0x, fx इज इक्वल टू 3x और fx इज इक्वल टू 6x। अगर हम Z9 से Z3 में बात करें तो भी only 3 homomorphisms will be there, because the GCD of 9 and 3 is also 3. But what are those? Okay, so in that case f of x is equals to 0x. Yes, it's possible, because क्यों ये होमोमॉर्फिज्म हो जाएगा कि 0 का जो ऑर्डर Z3 में है उतने ही ऑर्डर का एलिमेंट Z9 में भी है। ठीक है, उसके बाद अगर हम दूसरे होमोमॉर्फिज्म की बात करें तो 1x। अब 1 का जो ऑर्डर है वो 3 है Z3 में, है ना, और 3 ऑर्डर का एलिमेंट Z9 के पास भी है तो ये भी हो जाएगा। और क्या होगा, fx बराबर और क्या हो सकता है, व्हाट कैन वी से 2x, ठीक है, क्योंकि 2 का भी जो ऑर्डर है Z3 में 3 है और 3 ऑर्डर का जो एलिमेंट है वो Z9 में है। और हम Z3 में बात कर रहे हैं तो Z3 के पास एलिमेंट क्या है, 0 1 2, यही तीनों एलिमेंट्स है ना, तो इससे बियॉन्ड तो जाएंगे ही नहीं। तो Z9 से Z3 में भी 3 होमोमॉर्फिज्म्स ही होंगे, लेकिन होमोमॉर्फिज्म्स जो है वो अलग अलग होंगे। Z9 से Z3 की बात होगी तो f of x इज इक्वल टू 0x होगा, fx इज इक्वल टू 1x होगा, fx इज इक्वल टू 2x होगा। और जब Z3 से Z9 की बात हुई थी तो fx इज इक्वल टू क्या सब था, 0x था, 3x था, 6x था। सो यू हैव टू बी अ बिट केयरफुल टू से। ओके, so now I am going to ask one more question before coming to the shortcut formula. Okay, I don't appreciate just giving the answer without knowing the facts behind that, concepts behind that. Okay, I am not in a hurry to discuss the beautiful things in mathematics, and that's why I will discuss a question that if you are taking a map f from Z6 to Z12 and then find the number of homomorphism, people will say we can count it within seconds. I know you can do it, but I am not interested with your counting. I am interested in the concepts, the actual way why GCD of M and N is there. What is the reason behind that? I am interested in that, not just about the counting. Okay, certainly anybody can say the GCD of 6 and 12, which is 6. The answer is okay. But what is the reason behind that? How shall you illustrate it in your graduation days? Okay, so I am going to give you the full illustration of this. Okay, if you are given f from Z6 to Z12, possible order of elements in Z6 are what? What would you like to say? Possible orders are what? Certainly you will say 1, 2, 3 and 6, because these elements are going to divide this 6, right? Therefore, these are the possible orders 1, 2, 3 and 6. And what are the possible orders in Z12? What would you like to say? What are the possible orders in Z12? You will say 1, 2, 3, 4, 6 and 12, because these are the elements which is going to divide 12. So these are the possible orders in Z12. These are the possible orders in Z6. Okay. So what are the common orders? What would you like to say? We are interested in common orders. See, what is the concept behind it? These two are the common orders. These two are the common orders. These two are the common orders. And these two are the common orders. And we are interested in common orders only. So what are the common orders? What would you like to say? The common orders are 1, 2, 3 and 6, isn't it? Now what shall you do? I am interested in to find the number of elements of order 1 in Z12. Okay, because how many homomorphisms will be there? What will be the reason behind the actual things? So the common orders are 1, 2, 3 and 6. Okay, so now what shall we do? Number of elements of order 1, number of elements of order 1 in Z12 is what? Phi of 1, and phi of 1 is 1, Euler's phi function, you all know already, isn't it? So only one elements of order 1 are there, and therefore how many homomorphisms will be there? Certainly only one. And what is that? Oh, that is nothing but f of x is equals to 0x, only one. So this is the homomorphism, isn't it, for that particular order 1. 1 के लिए एक homomorphism मिला. ऐसा कर क्यों रहे हैं? कॉमन ऑर्डर की बात क्यों कर रहे हैं? क्योंकि अगर f of x इज इक्वल टू ax, अगर ये होमोमॉर्फिज्म है तो a का जो ऑर्डर z12 में है उतने ही ऑर्डर का एलिमेंट z6 में होना चाहिए, इसलिए कॉमन ऑर्डर की बात की है. तो नंबर ऑफ एलिमेंट्स ऑफ ऑर्डर 1 इन z12 एक है, तो f of x इज इक्वल टू 0x. एक होमोमॉर्फिज्म आपको मिल गया, मुबारक हो. नाउ number of elements of order 2, number of elements of order 2 in Z12 is what? Certainly this is phi of 2, and phi of 2 is what? 1. So what is that? Certainly f of x is equals to 2x. Yes. So this is also a homomorphism. Congratulations. But what are the interesting thing? Now we will find number of elements of order 3. Now we will find number of elements of order 3 in Z12. So number of elements of order 3 in Z12 is nothing but phi of 3, which is nothing but 3 to the power 1 minus 3 to the power 0, which is 3 minus 1, which is 2. So two homomorphisms will be from here. And what are those? Certainly you can say f of x is equals to 4x and f of x is equals to 8x. Okay, so these are the two homomorphisms. Now, what about the number of elements of order 6 in Z12? Number of elements of order 6 in Z12. What shall you say? Certainly this is phi of 6. And phi of 6 is what? 2. How? Because this is 6 into 1 minus 1 by 2. I am using general formula this time. So this is 6 into 1 by 2 into 2 divided by 3. So 3 2s are 6 and this is 2. So number of elements of order 6 is also 2. So two homomorphisms are from here. And what are those? F of x is equals to 2x and f of x is equals to 10x. Okay, so how many homomorphisms are over here? Two homomorphisms from the elements of order 6. Two homomorphisms from the elements of order 3, and one homomorphism from the elements of order 2, and one homomorphism from the elements of order 1. So total, how many homomorphisms are there? So total number of homomorphisms is equals to 1 plus 1 plus 2 plus 2, which is what? 6. And from here we are going to derive the formula. Are you interested? Okay, so we are just going to generalize this, and certainly we will get a beautiful formula. So hence we can see what? I'm just going to write the results that may save your time, and yes, I am also coming to that short tricks. Okay, so now I would like to write the result over here. So what are the result? Number of homomorphism, f from Zm to Zn is equals to GCD of m and n. Okay, we have verified this result from the previous examples. Here you can see 6 homomorphisms were there, and when you will find the GCD, the greatest common divisor of Z6, I mean to say 6 and 12, which is certainly 6. So it has been already verified, but yes, now you can count it. I have illustrated everything in a descriptive way so that you can easily understand, and an intuition should be there in your heart that एक्चुअली हाउ दैट होमोमॉर्फिज्म लुक्स, है ना. होमोमॉर्फिज्म तो इतने होंगे, लेकिन कौन कौन होंगे ये भी समझना ज़रूरी था, इसलिए हमने इतना इलस्ट्रेट किया. दूसरी बात, इफ़ D1, D2, D3 and by doing so DK are positive divisors of M and N. ये अगर पॉजिटिव डिवाइजर्स हैं किसके, M और N के, देन क्या हो जाएगा, phi of D1 प्लस phi of D2 and by doing so phi of dk is equals to GCD of M and N, and this has been verified, है ना. This has been verified. Here you can see this is what, phi of 6 which is 2 plus phi of 3 which is 2 and phi of 2 which is 1 and phi of 1 which is 1. So this 6 is what? This 6 is what? Before this you can see this was phi of 1, this was phi of 2, this was phi of 3 and this was what? Phi of 6, isn't it? And their sum is equals to GCD of 6 and 12, isn't it? So I have just generalized that. Okay, number of homomorphisms for the function f from Zm to Zn is GCD of M and N. Okay, so these were the things. And one more thing, if D1, D2, D3 up till Dk are the positive divisors of M and N, then in that case phi of D1 plus phi of D2 plus phi of Dk is nothing but equals to the GCD of M and N. So here is a very beautiful result. Now I will discuss the things very quickly. For example, if somebody will ask you the number of homomorphisms, f from Z8 to Z20, then its answer is so simple. You will just say it is nothing but the GCD of 8 and 20, and the greatest common divisor of 8 and 20 is what? Certainly 4. So 4 will be the answer. Okay. In the same manner, I would like to write some more results. You must remember that so that you can give the quick answers. Okay. Number of homomorphisms from f from Zm to Zn cross Zk. Okay, this is equals to nothing but the greatest common divisor of M and N into the greatest common divisor of M and K. Okay, so certainly these are the formula, and we can use it. So I am just going to give you a homework problem so that we can continue this lecture tomorrow. So the number of homomorphisms f from Z2 cross Z4 to Z8. How many number of homomorphisms will be there? By using the above formula, you can just say the things quickly, and we'll see you tomorrow at 8:30 p.m. Not tomorrow, I don't know I will be there at 8:30 p.m. tomorrow or not, but whenever I will get time, certainly I will come. So with this promise, I would like to say thank you very much. Anyone who will watch it recorded or anyone who is watching it now, okay, I would like to say thank you very much. Okay, we'll see you in the next class. You can check the playlist of this channel in which real analysis has been already completed. Okay, and many PYQs playlists are also there. So check out the playlists, and We'll see you in the next session. Till then, take care. Bye bye. Good night.